Welcome to your Algebra 2, Lesson 5.6, Video 1. Today you will find all real zeros of a polynomial function. Alright, now when you have a higher degree than 2, say x cubed, you're going to have to figure out some zeros, probably with methods other than just factoring. And remember, if we do synthetic division, and we have a 0, then you're going to get a remainder of 0. And so the idea would be that you start finding zeros by doing synthetic division, but you don't want to just pick any number out of the air. You want to pick one that could possibly work. And so there is a theorem called the rational zero theorem that helps you start with values that are possibly going to work. They help you rule out an infinite number of values that won't work. Okay, so if f of x equals amx to the n plus all the way down to a1x, which is x to the first power, plus a0, if that has integer coefficients, then every rational zero of f has the following form, p over q, where p is a factor of the constant term, the a0, and where q is a factor of the leading coefficient, an. So this is something you're going to need to know how to do. You're going to need to know that it's p over q, and that the p's are the factors of the constant term, and the q's are the factors of the leading coefficient. Okay, so we're going to practice this. We're going to practice just listing the possible rational zeros so that we don't have an infinite number of rational zeros to try. We have a finite number, a nice little list that if we had to, we could just start doing synthetic division with them until we find one that works. Okay, we're going to list the possible rational zeros of f using the rational zero theorem. You may hear me call that the rational roots theorem. Remember, roots and zeros are the same thing, and when I was in school we always called it the rational root theorem, so you'll probably hear me use both terms. Okay, so we have f of x equals x cubed plus 2x squared minus 11x plus 12. So let's just talk for a second. Our constant is 12. So that's going to be where we get our p's. Our leading coefficient is 1. So that's going to be where we get our q's. Notice that this is in standard form where we go in decreasing degree of x. It's very important so that you're looking at the correct coefficient for your q values. All right, so our p's are the factors of the constant term. Okay, it's 12. So you just start with 1. Everybody plus or minus 1 works. So you start with plus or minus 1. And then you go from there and you ask yourself, okay, does this integer work or not, until you get to the value of the constant itself, in this case 12. Okay, so you just go through and you go, okay, would 2 work? Yep, 2 is a factor of 12, so negative 2 is also. Does 3 work? Yes, because 12 is 3 times 4, so you have plus or minus 3. 4 work? Yep, it goes with the 3. 5 work? Nope, it's not an isolated factor of 12. 6, does 6 work? Yep, it's 6 times 2, so plus or minus 6. 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 doesn't work, 11 doesn't work, 12 works, and it is equal to the constant itself, so we know we can stop at plus or minus 12. Now, in this case, our q's are going to be easy because the coefficient of our leading term is just 1. So q, when we list our q's, again, it's the factors of the leading coefficient, it's plus or minus 1. Now on your notes, I want you to write out what p is. I want you to write out this factors of the constant term, for q, factors of the leading coefficient. But when you do your work, you can just do p colon and list all the factors of the constant term, q colon, all the factors of the leading coefficient. Now if you want to write out the description there, that's fine, but I'm just telling you don't have to. So now what we do is we do p over q. And these are going to be your possible rational zeros or possible rational roots. So you're always going to start with plus or minus because positive or negative are possible. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, plus or minus 12 over 1. And so then you do your simplified list, and so it's just plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Okay, and so if there are any rational zeros for f of x, it has to be one of these numbers. So if we were actually trying to find the zeros of this polynomial, what we would do is we'd start with, say, 1, and we'd do synthetic division with 1 to see if it's a 0 or not. If it is, great. The quotient would then be a quadratic, and we'd move on from there. If it's not, then we'd move on to -1, and then go to 2, -2, so on until we found a 0 that works. And we will see problems like that in just a minute. All right. So let's look at this next one. We've got f of x equals 4x to the fourth minus x cubed minus 3x squared plus 9x minus 10. So our constant term is -10, so that's our p-value. And then we look, we are in decreasing degree of x, so 4x to the fourth is our leading term, which makes 4 our leading coefficient. So our q's are going to be a little bit more interesting this time. All right, so let's list our p's, our factors of our constant term, -10. So again, you start with plus or minus 1, and then you go from there. Plus or minus 2 works, 3 doesn't, 4 doesn't, plus or minus 5 does, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 does, and that's the tie. It ties, it equals the constant, so we know we're done. So let's look at q. We want the factors of the leading coefficient. So of 4, so plus or minus 1 works because 4 is 4 times 1. Plus or minus 2 works because 2 times 2 is 4. Plus or minus 3 doesn't work. Plus or minus 4 does work, and it is equal to that coefficient, so we're done. Now this time doing our p's over q's is going to be a little more involved, okay? So we take each of the p values and we're going to match it up with each of the q values. So what we do is we take each of the p values and we work with the first q value, and then when we're done with that, we move to the second q value, and then we move to the third q value. So we're going to have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1. So now we're done with the 1. So we're going to have plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 5 over 2, plus or minus 10 over 2, and we're done matching everything up with the denominator of 2. So now we need to come back. We're going to do the same thing with our q value of 4 now as our denominator. So plus or minus 1/4, plus or minus 2/4, plus or minus 5/4, plus or minus 10/4. Okay, now we've got a big list here. They're not simplified yet. We can reduce some of these. What we're going to do is we're going to go through and we're going to reduce them, and we're going to look and see if that reduced value is already listed, and if it is, we're not going to write it down again because there's no reason to have it written twice. Okay, so the 1 over 1, 2 over 1, 5 over 1, 10 over 1 is going to give us the plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Plus or minus 1/2, that's reduced, that's new, so we write it down. Plus or minus 2 over 2, that reduces to plus or minus 1, and we already have that, so we just skip it. There's no reason to write it twice. Plus or minus 5/2, that's reduced, and it's new, so we write it down. Plus or minus 10/2 reduces to 5. We've already got that, so we don't need to write it again. Plus or minus 1/4, that one is reduced, and it's new, so we write it down. Plus or minus 2/4, that reduces to plus or minus 1/2, and we've got it, so we move on. Plus or minus 5/4, well, that's new, and it is reduced. It's okay that it's an improper fraction. The big thing is that it's reduced, so we go ahead and we write that down. Plus or minus 10/4, let's see, that reduces to plus or minus 5/2. We've already got that written down, and so we don't need to write it again. Okay, so we've made our list a little smaller, and it is all simplified. All right, let's do one more example on this video, and then we will move on to video 2, which will just have one example. All right, we're going to find all real zeros of f of x equals x cubed minus 8x squared plus 11x plus 20. All right, now you may look at this and go, well, couldn't we just factor? Well, you could try to factor by grouping, but that's not going to work for you. So what you need to know that, okay, if I can't do that, what I want to do is I want to do my p over q's. I want to find my rational, my list of all possible rational zeros. You need to understand that that's what you need to do in this case. Okay, it's not going to tell you to do that, but that's how you're going to get started. Okay. So on to our solution. For step 1, we're going to list the possible rational zeros, our p over q's, the leading coefficient is 1, right? The coefficient of x cubed is 1, and the constant term is 20. So our p's are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. And our q is just plus or minus 1. So here's our list of p over q's. So it's just everything, all our p's over 1, and we reduce it down. And our potential for real zeros, our x values, the ones we're going to plug in to synthetic division or synthetic substitution, is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Okay, so what we've done is we've gone from, there's an infinite number of integers. We've limited ourselves to just a finite list. Okay, if there is a rational 0, it has to be on this list. So there's no reason for us to check something like 3 because it's not on this list. But if we didn't have this way of limiting all possible values, why not try 3? So this really helps us out. Okay, step 2, we're going to test these potential zeros using synthetic division. And what we're looking for is we're looking for one that gives us 0 for the remainder, because that means that x value is a 0. All right, let's just start with 1, and we'll move on from there. So we're going to test 1. Remember, you put that value of 1 out here. Across the top here, you've got your coefficients from your polynomial and the constant. So our leading coefficient was 1, so we bring it down. 1 times 1 is 1. Negative 8 plus 1 is negative 7. Negative 7 times 1 is negative 7. 11 plus negative 7 is 4. Times 1 is 4. 20 plus 4 is 24, which is not 0, so 1 is not a 0. It did not generate a 0, so it is not a 0. So let's try negative 1. So everything on the top row stays the same except that we have negative 1 because that's the value we're testing. So we bring down the 1 times negative 1 is negative 1. Negative 8 plus negative 1 is negative 9. Times negative 1 is 9. 11 plus 9 is 20. Times negative 1 is negative 20. There should be a negative right there. I can fix that real quick. There we go. And so 20 plus negative 20 is 0. And so that means negative 1 is a 0. Okay? So if a value generates a 0, then it's considered a 0 of the function. Okay? Because negative 1 is a 0 of f, you can write f of x equals x minus negative 1, so x plus 1, times our quotient. So the quotient would have 1 degree less than our original polynomial, so 1x squared minus 9x plus 20. So that's what's here. They just let the 1 be understood. Okay, so now we've got a quadratic. We've got a nice little trinomial here. We can factor that. It's not a perfect square trinomial, but we can use guess and check or the AC method. You could also use the quadratic formula if you can't factor it. In this case, we can. So we're going to get x plus 1 times x minus 4 times x minus 5. And so we set that equal to 0. So we're going to have x plus 1 equals 0, x minus 4 equals 0, x minus 5 equals 0. So we get x equals negative 4. X equals negative 1, x equals 4, and x equals 5. So the zeros of f are negative 1, 4, and 5. Okay, so let's review the process again. You're given this polynomial. You can't factor it. So you go to plan B, which is to list your p over q's. Okay, you list all your possible rational zeros. Then you start testing them to find one that works. And once you find one that works, okay, we found that negative 1 was a 0. It works for us. You use that to create the binomial factor, and then you use your quotient to create the remaining factor. Okay. Once you get the remaining factor is a quadratic, you can either factor it, or if it's prime, what you're going to do is you're still going to set that quadratic equal to 0, and you'll just use quadratic formula. Okay. When we come back for example 3, we're going to look at what happens. Well, what if it's x to the 4th instead of x cubed? So I'll see you in a couple of minutes.